Can anyone refresh our memory on the indeterminate cases that we looked at? We know the total is 7. We haven't seen all of them, but can anyone refresh our memory and on how many we saw and which ones?
Infinity over infinity.
Excellent.
0 over 0.
Excellent. I don't really need the third one, but the third one is this.
Oh yeah, infinity minus infinity.
Good. I really needed these two. So only in these two situations, when we have a limit of a function over another function, let's say as x approaches a, only in these two situations, 0 over 0 or infinity over infinity, no other case, just these two. So again, let me just emphasize. Ratio 0 over 0 or infinity over infinity. Number 1, ratio. Number 2, these two cases. And number 3, a limit. So this is number 1. It has to be a ratio. The answer, of course, number 2 should be, doesn't matter. All these have to be in place. Ratio, limit, and the answer, initial answer, 0 over 0, infinity over infinity. Only when these 3 are fulfilled, we can use, not if this is missing, not if this is missing. Of course, all these 3 have to be fulfilled. We can use L'Hopital, that's his name, L'Hopital's rule. He said this: if there is a limit of a ratio and 0 over 0 or infinity over infinity, if all these conditions are fulfilled, then I can determine the limit as x approaches a from f of x over g of x. I can write this: limit as x approaches a from either side, or one side, it doesn't matter, from f prime of x over g prime of x. We are not differentiating the quotient. We cannot. The quotient rule is very clear. The quotient rule says this. But not when there is a limit in front. If there is a limit in front of this, and we encounter one or the other of situations, then we are allowed to, again, ratio, limit, and one of these two, we are allowed to keep the limit. If you drop the limit, then the whole thing fails. We are allowed to write the limit of the derivative of the top and the derivative of the denominator completely separate, not applying a quotient rule. Why? This is a limit. If there is no limit, then we have to apply the quotient rule. But there is a limit, there is a ratio, and the answer is one or the other. Then I can do this. So can anyone give us a limit from the past? Any limit from the past, so we can illustrate any limit. It could be from the test. It could be any limit that it took us 5 minutes to solve or get. Just to illustrate with L'Hopital's rule. This is in chapter 4. However, I cannot wait till chapter 4. This is too important to apply it as soon as possible.
Limit as x approaches to 2 minus x.
You said
2 minus x over square root of x plus 2 minus 2. Outside of the, yeah.
Good. So the numerator is 0, going to 0 when I plug in 2. And this is the square root of 4, which is 2. 2 minus 2 is 0. All conditions are fulfilled. Limit, ratio, 0 over 0. Limit, ratio, and one or the other. So now let's see. Limit x approaches to. I'm not saying that it's not easier to rationalize. I'm only saying that this is another way. Sometimes this will be the only way. Sometimes it will be easier, sometimes it will be more difficult. We're not forced to ever use L'Hopital's rule. We apply L'Hopital's rule if it makes our life easier. In this situation, it may not, but we want to illustrate. Okay, good. Now, there is a little bit of a problem with this function because we have not talked about the chain rule yet. We have not talked about the chain rule yet. So there is a little bit of an issue here. The chain rule is in 2 sections from now. But I'll guide you through this. Okay. So first we differentiate the numerator. Again, we're not applying the quotient rule here because it's a limit. 1, 2, 3. Okay. Can anyone give us the derivative of the top?
-1.
That's it, -1. Good. Now, the denominator, when I differentiate this, I'm going to get 0. So I only have to differentiate this. Okay, so when I have a square root of a function, I get 1 over 2, the square root of that function, which is x plus 2. And I have to, that's why I keep saying times the inner function prime, but it's still 1. So don't worry about it. I'm going to explain in detail when we get to the chain rule. Now, I apply L'Hopital's rule because of 1, 2, 3. And now let's apply the limit again and see what we get. Now the limit operator disappears. So the numerator obviously goes to -1. Where is the denominator going?
See 1 over 4.
1 over 4. Flip and we get -4. I couldn't show you this and you couldn't use it for test 1, but we will be able to use it for test 2, 3, 4, and the final. But remember 3 conditions. Limit, ratio, and 0 over 0. Okay, good. Moving on to (3.3) derivatives of trig functions. You'll see why I needed that. And before I forget, there is something called the derivatives quiz, not quiz, the derivatives skills assessment, something like that. Derivatives assessment, yes, that's what it's called, which is due before the test. No other assessments are due for the rest of the semester, but there is one called derivatives assessment, and it's due before test 2. So please start working on it. It's just 2 pages, 20 points, I think. Start working so you can ask questions of similar problems, okay? So please start working on that. So we have 6 trig functions. And of course, and their inverse functions, etc., etc. But for now, we're talking about the 6 trig functions. Sine, cosine, tangent, cotangent, secant, and cosecant. We can prove any of the sine and cosine. It will take about 10 minutes for me to prove any of these 2 if you'd like to. or I will just show you the first two and I'll give them. So let's say this is cosine. So sine prime is cosine. Cosine prime is negative sine x. And the rest we can develop very easily. We will have a little bit of a problem with secant and cosecant because we haven't studied the chain rule yet. But let's say we come up with a tangent. So we want to determine tangent prime. Can anyone tell us what does tangent equal to?
Sine over cos.
Very good. So let's differentiate this. No problem. The denominator, it's a quotient rule. Cosine prime, I'm sorry, I meant to say cosine squared. Sine prime, which is cosine, times cosine. Watch me run out of room again. Minus sine x times cosine prime, which is negative sine x. So this is cosine squared, but plus sine squared. Over cosine squared. Do not attempt to simplify anything. Does anyone remember how much this is?
1.
Very good. Thank you very much. And does anyone remember what is 1 over cosine in general?
Sec.
Very good. Perfect. So then tangent prime is secant squared. Cotangent prime is negative cosecant squared. Secant prime is secant times tangent. And cosecant prime is negative cosecant cotangent. These should be carved in stone, please. Any questions so far? I know I only have a few more minutes. I want to ask you about this. It's a very important limit. So what is the first thing we need to do when we're asked to find the limit? First thing ever.
Plug it in.
Plug it in. So when I plug it in, where is the numerator going and where is the denominator going?
Zero.
Good. And the denominator?
0.
Excellent. So 1, 2, 3. If I have 1, 2, 3, what do I do?
We use the rule.
L'Hopital's rule. Excellent. Excellent. Good. So I have limit as x approaches 0. Please differentiate sign and tell me what to write.
Cos x.
Very good. Please differentiate x and tell me what to write.
1.
Good. Can you determine the limit now?
One.
Excellent. Great job. Thank you. Perfect. Okay, I know we have 7 minutes left. I'm going to share my screen. I'll let you choose. We're going to talk about those limits on Wednesday. You're not responsible for 3.3, but please, with 60%, please finish 3.1 and 3.2. So let's choose any function from here, from 1 through 22. Anything you want, 1 through 22, to work on and find the derivative.